Okay, electricity and plumbing. This is Mr. Voigt. We're going over the combination circuit for a parallel series circuit. What that means, the main circuit is a parallel circuit. See, two paths for electricity flow in this main circuit, and inside there you have two. We have to treat these like two series circuits from that point to that point and that point to that point. So in these two series circuits, because there's two resistors, we have to collapse those down into one. We call that resistance combined 1. That's what RC1 stands for. And over here, we combine 3 and 4 into resistance combined 2. So R3, R4, and RC2 are all in series. So this is our total for that one. R1, R2, and RC1 are all in series. But the two combined ones, RC1 and RC2, because now they act, because they're the total here, it's like one resistor. And RC1 is like one resistor. We can treat those, RC1, RC2, and RT, as in parallel. So that's how we're going to use our rules to solve this. So I've already copied down the 1 amp in my chart. I've already copied down all of these 4 ohms. And I already took the step of, if you remember, I just got done telling you, R1, R2, RC1 are in series. So if you remember the rule for a series circuit, resistance, the total resistance for that circuit is the sum of the resistance points. So I added those together. Over here it's the same thing. I added these together. So that's where we're at right now. So now we can treat RC1 and RC2 because those are in parallel with our total. We can use this and this to use our reciprocal formula. So I'm going to go 1. For ours it'll be 1 divided by 1 over 600 plus 1 over 400, because our 600 is here and our 400 is here. All right. Now, so I've already added these up, so now I got to type this into the calculator, and the way you type this into a calculator is going 1 divided by, and then you got to go open parentheses, 1 divided by 600, and I got to close my parentheses because I want to do this operation first. And then I got to go plus, open parentheses, 1 divided by 400, close parentheses, close parentheses. So I want to do the division first, the addition second. That's what these second set of parentheses for. And then the last division, the 1 over, last. And I get 240. So I have 240 ohms right here. And the rule for ohms in a parallel circuit is my total is less than the resistance in any branch. So 240 should be lower than either one of these two numbers, and it is. So I'm following my rule of resistance in a parallel circuit. So I think I'm okay. So now I only have 2 variables in this spot. So I'm going to find volts. To find volts, I multiply these together. It's always amps times resistance gets you volts. So amps times resistance is going to be 1 times 240 is going to be 240 volts. All right. 240 volts then can be distributed, because if you look at your rules for volts in a parallel circuit, applied voltage is going to be the same in each branch. So we're going to go here with your 240 volts and here. So applied voltage is the same voltage that goes through each branch. And essentially, you collapse these two down into one resistor here. That is my branch. Collapse these two down into one, and that is my branch. Now, we don't know how much of that 240 goes there or there. 240 goes there or there. We'll figure that out here in a minute. So now we have 2 variables here and 2 variables here. We're going to find our amps, because if we find amps, and we know this is a series circuit, amps are the same at the total and each resistor in a series circuit. So if I find this, it can go there and there. If I find that, it can go there and there. And once I do that, I have 2 variables everywhere. So to find amps, volts divided by resistance, so 240, I should put this in the view here, divided by 600, and we got 0.4. So we're going to go 0.4 here. And I can tell you right now, knowing my rules for it, because this is in parallel, right? And this is in parallel with this. The rule in a parallel circuit is amperage in the branches of my circuit will add up to my total amperage. So if I have 0.4 in this branch and I know my total is, it should be 0.6 here because I follow my rule. Now I can also divide 240 by 400 and I should come up with the exact answer. 0.6. So you see the rules and the formulas do work together. So once I get this one, just like over here, I can, because this is a series circuit, I get to apply that voltage here and here. And so now I have at least two variables every place. So to find voltage, I multiply amps times resistance, amps times resistance, amps times resistance, amps times resistance. So I'm just going to do that. 325 times 4. And I come up with 130. And now, because I know my rules, in a series circuit, my voltage drops on my resistors should add up to 240, so this should be 110 when I do it. 275 times 0.4, 110. It really helps to know your rules. 150 times 0.6, so that's 90. So if I take 90, I should have, what, 150, right? Because that plus that should equal that. This is a series circuit. But I'll go ahead and do the math anyway. 250 times 0.6, and I get 150. Okay, so I've done all my Ohm's law stuff. My wattage down here is simply volts times amps is my watt. So 240 watts. Okay, 130 times 0.4, 52. And if you remember the rule for watts in a circuit, when we have 52 and whatever is R2 is, we'll get our RC. When we add R3 and R4, we'll get our RC2. And if I add RC2 and RC1, I should get my 240. Or I can add 1, 2, 3, and 4, and I should get 240 as well. Okay, so 110 times 0.4, 44. Okay, so this plus this is going to be 96, right? But if I want to do the calculation, I can. 240 times 0.4, I'm going to get 96. So I hope this shows to you that the rules work. 90 times 0.6, the rules and the formula work. 54 watts. 150 times 0.6, 90 watts. So that's going to be, if I add those together, what? 104 watts. So 240 times 0.6, I get 144. If I add 144 and 96, I'm going to get 240. Okay? So I could do it on the calculator, but I'm telling you, those add up. If I add 90, 54, 44, and 52, I'm going to get 240. So that's how you do this combination circuit. Those are your answers. Actually, I think I said earlier, this is your practice. I think this is the first explanation on how to do this.